इस पे क्लिक करें। Good evening, everyone. Welcome to Aspire IES. Myself, Mohit. From today, we are going to start our chemistry optional revision series for the Civil Services Mains Exam 2021. Addition to that, we are starting a test series for the chemistry optional so that you can get double benefit. First, through this revision lecture series, you will be able to revise your topics thoroughly. Addition to that, you will be getting writing practice. I'll be reviewing your questions and will be giving you feedback, and I will be telling you what all topics you should include in a question to get maximum marks. So from today we are starting with the atomic structure topic. So in the atomic structure, every year you will get minimum two questions. One from the Schrodinger wave equation, that is definite, and additional to that you can get a numerical also generally from Schrodinger wave equation, or you may get to write the shapes of the various orbitals, and these are very easy questions, but if you don't do it you will be at a loss because most of the people will be able to do it. Now in the from the beginning, now the atomic structure starts from the Rutherford model. Now what the Rutherford model says about the atomic structure. Now Rutherford model says that in an atom there is a nucleus at the center, positive charge, and an electron is moving around it. Now the flow with this model is that since the positive and negative charge are opposite charge, so they must attract each other. Now, once they attract, negative charge should eventually merge with the positive charge. Additionally, there is a concept of physics that when a charged particle is accelerating, it will lose its energy. And since electron is moving in a circular path, it is always accelerating. So it will lose its energy, and eventually the electron will merge into the nucleus following a spiral path. So due to this model could not explain the stability of the atom. Now, according to that, no atom must be stable, but we know many elements, for example, iron, it is highly stable. So this model was disregarded. Now the next model came was Bohr's model. Now, what Bohr said? Bohr said that the electrons are moving in circular path around the positive charged nucleus. Now these circular paths are fixed. So he gave the solution to the first problem, that the electron will submerge in the nucleus. So that will not happen. These paths are fixed. Additionally, electron will gain or lose energy only when it changes its energy level. So the energy levels are fixed, and once the electron gains the energy, only then it will once the electrons lose the energy or gain the energy, it will change its orbit. So the problem that was with Rutherford, that it will submerge in this, that will not happen. Another postulate of Bohr was that this model is applicable only for single electron atoms. That means atoms like hydrogen or He plus or Li2 plus only, and so on. Only atoms like that, this model is applicable. All right. So, but the issue with and on solving on application of this, he was able to get give some basic idea about the atomic structure. Using this model, he gave the formula for energy, that was minus 13.6 z square by n square. All right. So the energy, according to the energy of electron in an atom, according to Bohr was minus 13.6 z square by n square. Here z is the atomic number, n is the energy level in which electron is present. Now, but and according to this, Bohr explained the spectra of the atom. Now, how he explained the spectra? Now, as he said, upon gaining energy, electrons move from one energy level to another. Upon gaining, they move to higher energy level, and upon losing, they move to lower energy level. Now, when an electron absorbs an energy and comes back to the ground state, it on releasing energy, it gives spectra. So these are the energy levels 1, 2, 3, 4, and so on up to infinity. Now he gave various spectral lines for hydrogen atom. Any line that is reaching up to energy level 1. This one was Lyman series. From infinity till to 1. N1 is equal to 1 and N2 is equal to 2 to infinity. These all belong to Lyman series. Second one belong to Balmer series. Balmer series started up to 2. From infinity till an energy level of 2. N is equal to 2. So from n is equal to 2, n2 will be equal to 2. Sorry, n1 will be equal to 2 and n2 will be equal to 3 to infinity. So according to this was Balmer. Similarly, next range was Bastian, bracket, and then it was Pfund, and last was Humphrey. These are the name of the series. Lyman was from infinity to n1 is equal to 1. That was Lyman. N1 is equal to 2. That is Balmer. N1 is equal to 3. That is Bastian. N1 is equal to 4. That is bracket. N1 is equal to 5. This is Pfund. And N1 is equal to 6. That is Humphrey. In this, the line that is starting from infinity is called the limiting line. So when n2 is equal to infinity, it is the limiting line. When n2 is equal to 2 for Lyman, then it is alpha line. When n2 is equal to 3, then it is beta line, and so on. So if they ask you to calculate the energy of wavelength of alpha line, so you will be taking n2 is equal to 2 and n1 is equal to 1 for Lyman series. They will be giving you the series and they will be telling you to calculate the wavelength. Now how will you calculate the wavelength? That will be calculated through Rydberg formula. Now what is this Rydberg formula? Rydberg formula is 1 by lambda is equal to RH into Z square 1 by N1 square minus 1 by N2 square. Here N1 is the energy level up to which the electron is moving. N2 is the energy level from where electron is moving. Z is the atomic number. RH is the Rydberg constant. Rydberg its value is 109677 centimeter inverse. Alright, so using this formula, you will be easily able to calculate the wavelength of the line spectra of any series. Suppose they give you to calculate the uh, spectra limiting line for Balmer series. Now here for hydrogen atom, or you may say for lithium Li2+. Since it is only applicable for one electron system, so they will be giving you Li2+. Now here for Li, Z is 3, so you will be putting Z is equal to 3. N1 for Balmer series is 2, and 2 for limiting line is infinity. Upon putting this, we can easily calculate the value of wavelength. Okay, so this is simple things. Now after the Bose model, there were some issues. What were the issues in the Bose model? First of all, he did not tell. First of all, there was it was only applicable for single electron system. So the Bohr model limitation were only for single electron. Additionally, he gave the concept of angular momentum. Quantization of angular momentum. angular momentum, that is mvr is equal to nh over 2 pi. Now there was no mathematical basis from where he got this concept. Additionally, he could not explain the splitting of spectra in presence of electronic and magnetic field, electric and magnetic field. Now due to this, the Bohr model failed. Now then came the concept of wave, wave particle duality by de Broglie. Now what de Broglie said? De Broglie said that like wave has dual nature, both particle and similarly particles also have dual nature, both particle character and wave character. So every particle in the universe have dual nature, both wave character and particle character. Total character remains same, one is dominant. For example, in light, wave character is dominant. In particles, particle character is dominant. Accordingly, he gave the formula of duality, de Broglie's wave particle duality. Since they have both character, so energy from particle character as well as energy from wave character, they must be equal. So energy from particle character we calculate by the E is equal to mc square, and energy from wave character we calculate E is equal to hc by lambda. Now upon equating this, we get lambda is equal to h upon mc or h upon p. P is momentum, h is Planck's constant. Okay. So additionally, there is another formula for wavelength, that is lambda is equal to h upon root 2 m ev, where E is charge of electron, V is potential across which the electron is moving. So by this we can calculate the wavelength by which the electron is moving around the nucleus. Then came the theory of uncertainty by the Heisenberg, that we say Heisenberg uncertainty principle. Now what Heisenberg said? Next theory was Heisenberg's uncertainty principle. Now what Heisenberg said? Heisenberg said that for any subatomic particle, it is impossible to exactly calculate its momentum and the position at the same time. So we cannot calculate the momentum and position of a moving subatomic particle at the same time. That was Heisenberg uncertainty principle. But up till now, we were trying to calculate this simultaneously. So that means there is a concept of uncertainty. That means we cannot calculate exactly the position of electron. We just can find out that what is the probability of finding an electron around the nucleus at a certain position. That is all what we can calculate. That was the derivation from Heisenberg. Now the mathematical formula for Heisenberg is delta x into delta p is greater than equal to h upon 4 pi. Here delta x is the uncertainty in the position, delta p is the uncertainty in the momentum, h is the Planck constant. So that means there is the minimum certainty in calculating momentum and position is h upon 4 pi. It will be greater than that or equal to that. In addition to that, we can say delta E into delta T is greater than or equal to h upon 4 pi. How this is calculated? Now P is equal to momentum हो गया, P square by 2m is energy. This is half mv square. When we multiply denominator and numerator by m, we get p square by 2m. Upon differentiating, delta E is equal to 2p delta p 2m. And from here, delta E is equal to, now what is p? P is mass into velocity. This get cancels. Now velocity is delta x by delta t. So delta E is equal to delta x by delta t to delta p. From here we get delta x into delta p is delta into delta t greater than or equal to h upon 4 pi. So if in the question they give you the uncertainty in calculation of energy, you can tell the uncertainty in time. So this is Heisenberg uncertainty principle. Now from all this, we scientists now started to find out new models of explaining the atomic structure. And then we got they found out various models, but in our syllabus we only have to study the Schrodinger wave equation model. Now that from that we will be doing from the next class. So thank you. This was the introductory class. We will be continuing this type of lectures regularly up till the mains exams of civil services 2021. Thank you.